Okay, imagine this. You lose 5 full days a year. Not on holiday, no, but just stuck in gridlock. That's the reality for an average person in Kathmandu, Nepal.
It's pretty stark when you put it like that.
It really is. So today we're doing a deep dive. We've got a stack of sources, academic studies, local reports, news articles, all looking at why Kathmandu's traffic is, well, so notorious.
Right.
And more importantly, what solutions are actually being talked about? Are they innovative? Are they working? That's our mission today.
Yeah.
Pull out the key insights, the surprising bits, the aha moments, so you can quickly get a handle on this huge challenge of urban mobility in a city that's growing so fast.
And what's really fascinating, I think, is that it's not just, too many cars on the road. That's part of it, sure. But it's much more layered. You've got complex urban planning issues, technology playing a role, or maybe not playing the role it could, and crucially, human behavior.
Human behavior, right.
Yeah. We'll see why some of the fixes you might think are obvious, well, they haven't quite worked out. And what a truly integrated approach might need to look like for Kathmandu.
Okay, so let's kick things off with the sheer scale. How bad is it?
Well, the numbers are pretty eye-watering.
Over 100,000 cars in the city. And the sources, they describe the congestion as raging.
Raging, yeah. That paints a picture.
And that stat we started with, 120 hours a year, losing 5 full days, it really frames the impact on people's lives, doesn't it? Just waiting.
Absolutely. And it's been getting worse. The vehicle numbers, they just exploded.
Yeah, I saw that. From about 53,000 in 2011-12 up to nearly 120,000 by 2016-17.
An alarming trend is how one source put it, even, factoring in the pandemic slowdowns later on.
And the cost, not just time, but actual money.
Yeah, the financial hit is huge. An estimated 16.5 billion Nepali rupees.
Wow.
Annually. Just lost. Wasted time, extra fuel burn sitting in traffic. That's a massive drag on the city's economy.
It really is. So what's driving this? Is it just more people?
That's part of it, population growth definitely. But the sources really emphasize this widespread preference for private vehicles. And specifically, it's the two-wheelers, motorbikes. They make up nearly half, 47% of how people get around.
Compared to public transport?
Only 23% for public vehicles, and cars are just 11%. So yeah, motorbikes are dominant.
I see.
And then you add in other things. People disobeying driving laws, the roads themselves being in poor shape, intersections that are badly managed.
Broken streetlights, too, I read.
Yep. Haphazard parking, especially in the busy core areas. Street vendors setting up wherever they like, adding to the blockage, and just general recklessness, as one source calls it.
Yeah.
People trying to take cars down super narrow old streets like Asan, which were clearly never meant for them.
Yeah, that makes sense. Now, this next point, this one really made me pause. It's this idea that making highways bigger has never been a solution.
Ah, yes. The induced demand concept.
Exactly. One analysis apparently shows congestion just goes up linearly with how wide the road is.
It's fascinating, isn't it? Because it feels so counterintuitive. You build more space. Surely that helps.
You'd think so.
But no. More road capacity often just encourages more people to drive or to drive longer distances. And poof, the new space fills right up.
So it completely flips that conventional thinking. You can't just build your way out of congestion.
Precisely. It forces you to think smarter about managing the demand itself, not just supplying more road. And that's a much harder problem to solve than just pouring concrete.
Okay, so if wider roads aren't the silver bullet, what are the solutions being explored in Kathmandu? The sources mention a whole range, right? Technology, behavior.
Yeah, it's quite a spectrum. Let's get into some of those. One big area is intelligent traffic management systems.
So smart traffic lights.
Kind of, but much smarter than just a timer. The idea is using CCTV cameras, computer vision, to actually see the traffic in real time. How dense is it? What types of vehicles are there? Cars, bikes, buses, rickshaws? And then the system automatically figures out the best green light times.
Right, adapting on the fly.
Exactly. And the simulations looked really promising. One study showed this kind of adaptive system could handle almost 3,000 vehicles an hour.
Compared to?
Compared to about 2,400 with the current static lights. That's what, over a 23% improvement?
Wow. That's like 48 extra vehicles getting through every 5 minutes.
Makes a real difference in peak hour. And the advantages are pretty compelling. It's real time, apparently needs virtually no new hardware, just using existing cameras, so it's cheaper than installing sensors everywhere. And it runs itself. It's autonomous.
That sounds very promising if they can implement it effectively. So that's the tech side. What about physical changes to the roads themselves if widening isn't the answer? Any clever engineering ideas?
Oh, definitely. The sources talk about creative road engineering, things like roundabouts.
Ah, like they have a lot in Europe.
Exactly. Proven to cut down on fatal accidents and generally improve flow. Plus, they don't need traffic lights. Meta-Harmandala is mentioned as an example already there. And another really interesting one is a reversible lane system. They explored this for the Aranaco Highway between Jatabuti and Koteshwor.
How does that work?
The idea is you take the central lanes, maybe 4 of them, and you switch their direction based on peak traffic flow. So in the morning rush towards Koteshwor, those lanes go that way.
I see.
And in the evening peak, going back towards Jatabuti, you reverse them.
Clever. Did the simulations show benefits for that too?
They did. Big reductions in queue lengths, like 50% at Lokanthali in the morning, over 50% at Tinkun in the evening. And travel times improved too, around 11% on average, but up to 19% better on one stretch in the morning.
That's a smart way to squeeze more capacity out of existing roads without major construction.
Oh.
Okay, so we have tech, we have engineering. What about people? Policy changes, behavior?
Yeah, absolutely crucial. Lane discipline comes up a lot.
The basics, right. Stay in your lane, signal.
Use signals, don't tailgate, keep right unless you're overtaking, don't block the passive lane. It sounds simple, but the sources stress how vital it is and how often it's ignored. Then there are policy ideas like localization of institutions, basically restricting new schools, colleges, government offices from setting up in already jam-packed areas.
To spread out the traffic generation.
Exactly. Reduce those peak hour surges, make it safer for pedestrians, cyclists, maybe encourage more public transport use if things aren't all clustered in one spot.
Makes sense.
Related to that is time shift, just staggering the opening and closing hours for big institutions like schools and offices.
Do they have examples of that working?
Yeah, they mentioned Chandigarh in India tried something similar and apparently saw about a 10% average reduction in congestion.
Interesting. Small changes can add up.
They can. But underlying all of these technical and policy fixes, the sources always come back to public awareness.
The human element again.
Always. As one source nicely put it, while science cannot alter your perspective on the world, it may unquestionably alter what you observe. Getting people to understand the why behind the rules, the impact of their choices. That's seen as fundamental.
It really sounds like you need everything working together. Is there a big master plan trying to connect these dots?
There is, thankfully, the Kathmandu Valley Urban Transport System Master Plan. It's a joint project between JICA, that's the Japan International Cooperation Agency, and the Nepali government.
Okay, JICA's involvement suggests a serious, long-term approach.
It does. They're a major player in development aid. The plan aims for a comprehensive, sustainable system, really focusing on mass transit, especially looking ahead to a projected population of nearly 3.8 million by 2030.
So data-driven, coordinated policy, that sounds like what's needed.
Exactly. Pulling all those threads together.
Okay, so we've talked about the problems, the potential solutions, tech, engineering, behavioral, big plans. Now let's zoom in on a specific project that's been, well, let's say controversial. The Gwarko Overpass.
Ah, yes, the overpass.
It was talked up as a potential game changer for that really messy junction, wasn't it?
It certainly was.
Yeah.
Heralded by many.
But the reality seems quite different. Sources suggest it's basically just shifted the traffic jam somewhere else, frustrated local drivers, and raised questions about how millions of rupees were spent.
That captures the criticisms pretty well. First off, it's seen as a partial solution. It really only helps the traffic going straight through in the central lanes.
What about turning traffic, local traffic?
Exactly. The vehicles on the service lanes, which handle most of that local and turning movement, they're still choked during peak hours. So for many people using that junction day to day, not much has improved.
Right, and the idea of shifting the problem.
Yeah, that's the second big point. Reports say congestion has actually gotten worse further down the road, at Koteshwor and Satdobato. The overpass lets traffic flow faster through Gwarko, but then it just slams into the next unprepared junction.
Like squeezing a balloon, the bulge just moves.
Precisely. It highlights a lack of system-wide thinking.
And what was that about the traffic lights? That sounded bizarre.
It really is. An odd and frankly baffling observation, one source called it. During rush hour, the traffic lights at the overpass junction are often just off or not working.
So how is traffic managed?
Manually. by like 3 or 4 police officers trying to direct this overwhelming volume of traffic, which, as you can imagine, leads to pretty chaotic vehicle movement.
Unbelievable for a brand new overpass.
Mm-hmm. Some sources even made the ironic comment that the main function of the overpass seems to be providing shelter from the sun or rain for the traffic police.
Ouch. That's a harsh assessment. Does this point to poor planning overall?
The sources definitely strongly suggest a lack of comprehensive study and planning. There's a feeling it might have been rushed or politically motivated.
Rather than based on solid traffic analysis.
Exactly. Not enough thought given to how it integrates the signals or traffic patterns or even planning for diversions during construction. And speaking of construction,
Delays and cost overruns, let me guess.
you guessed it. Started in Feb 2022, meant to take 2 years, so finished by Feb 2024. Significantly delayed. As of early 2025, work had apparently stalled for over a month after already being suspended for 4 months during the monsoon. There were technical issues too, a ramp needing to be dismantled and rebuilt.
Oh dear. And the cost?
Ballooned. The contract was about 170 million NRs. They'd already spent 440 million by early 2025 and estimated needing another 150 million to finish.
Wow. So more than double the budget, maybe triple by the end?
Yeah.
And still not fully functional.
Seems that way. Big questions about project management.
But wait, didn't you mention earlier that simulations showed an overpass could work there?
Yes. That's the crucial distinction, isn't it? Between the theoretical potential and the messy reality of execution. A
Right.
separate study, using proper traffic simulation software, Sesudri it's called, did find that if you had the geometric improvements of the flyover and optimized signal timings, you could cut the average delay right down to about 26 seconds per vehicle.
Which would be a huge improvement.
Huge. That gets you to what engineers call level of service C, stable flow, much better than gridlock. So the potential was there on paper.
But the implementation.
Fell short. Interestingly, that same study also found that trying to coordinate the signals between Gwarko and nearby intersections wasn't actually as effective as just optimizing the signals at Gwarko itself in isolation, probably because the junctions are quite far apart.
So nuanced findings, even in the simulations.
Yeah.
Okay, the Gwarko Overpass really does sound like a cautionary tale.
It really does.
It just hammers home that throwing concrete at the problem isn't enough.
Yeah.
You absolutely need that smart, adaptive, multidimensional approach we were talking about.
Precisely. And that's the big takeaway from the sources for any city dealing with this, not just Kathmandu. You need that data-driven urban mobility planning. You need technology-enabled traffic signal control. You need integrated transport policies that actually reduce the reliance on private cars.
And that's about the what, but the how as
Okay.
well, right? Project management, site investigation.
Absolutely. Proper planning, contingency planning. We've seen massive infrastructure projects elsewhere, like Boston's Big Dig, run into similar issues with huge delays and cost overruns when these things aren't handled well.
Right.
Ultimately, as the sources suggest, it comes back to fostering that society-friendly mentality, combining it with effective, genuinely inventive approaches, and making sure the public is aware and on board. That seems key for long-term success.
So Kathmandu's traffic struggles, while extreme, really hold lessons for rapidly growing cities everywhere. It's a complex puzzle, and the solutions clearly need to be more sophisticated than just building more roads.
Which leads to, I think, a really important final thought, or maybe a question for everyone listening. If the simulations, the data, clearly show the benefits of optimized systems, smart signals, better road design, and we also know that changing behavior and public awareness are vital, how do cities actually bridge that gap? The gap between the theory, the potential solutions, the messy reality of construction projects like Gwarko, and just the day-to-day grind for commuters. What role do you think individual choices and public pressure really play when faced with these huge infrastructure challenges?